أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students, Assalamu alaikum wa rahmatullah. As you know, we are discussing S&P block elements. So far, we have discussed some important concepts regarding these S&P block elements. In the previous lecture, we have studied how the first element of each group shows anomalous behavior than the rest of the elements of the same group. So in that we have seen that the first element of each group has small size, it has very high ionization energy and very high electronegativity, and these elements, the first element of each group, they don't have vacant d orbitals, and among them the positive ions, those first elements which form the positive ions, they have very high polarizing power. So these some important pointers make the first element of every group to behave somewhat differently than the rest of the elements of the same group. Though one thing should be kept in mind, that and maximum of the properties the elements of the same group resemble with each other because of their same electronic configuration. But in some cases, in certain cases, we observe that first element shows somewhat different behavior, and that different behavior is because of the differences in the properties which I have just now mentioned. Now today we will move forward and we will discuss some other general characteristics, and among those general characteristics, one of the properties is which we call atomic radius or atomic size. Actually the property is atomic size, but this atomic size is explained on the basis of atomic radius. We know that elements are generally considered to be spherical in shape. So, the size of a sphere is best expressed in terms of its radius. As you know, the radius is the distance from the center of the circle to the circumference. And in case of atoms, we say the atomic radius is the distance between the center of the distance between the center of the atom that is nucleus, and the outermost shell, and that outermost shell is called as valence shell. So this distance from the nucleus up to the outermost shell gives us the atomic radius. So greater the distance, larger is the atom. Greater the distance, larger is the atomic radius or larger is the atomic size. As we move down the group from lithium, sodium, potassium, rubidium, and francium, cesium and francium, from top to bottom. This is the case in every group. Whenever you move from top to bottom, we know that the size of the atom goes on increasing. It is because down the group, number of shells goes on increasing. In case of lithium, there is K shell and L shell, nucleus, then there is K shell, then there is L shell. There are two shells. While as in case of sodium, there are three shells, nucleus, K shell, then it is L shell, and then it is M shell. So, in the same way, in case of potassium, there will be four shells. So the number of shells goes on increasing down the group. So down the group, when we move from top to bottom, the size of the atom, or you may say atomic radius, goes on increasing. And this increase in the size of the atom is due to the addition of new shells. As you have seen here, in case of group first, in lithium there are only two shells, while as in sodium there are three shells. When you will go to potassium, there will be four shells, and that means number of shells goes on increasing. When the number of shells increases, the distance between the nucleus and the outermost shell increases, that is atomic radius increases. So the first simple point is that atomic radius goes on increasing from top to bottom. But at the same time, if we will move from left to right, suppose there is lithium, after lithium, we know there is lithium, after lithium there is beryllium, and then there is boron, then there is carbon, then there is nitrogen, oxygen. When we move along a period from left to right, we observe that number of shells remain the same. And in lithium, there are two shells. When you will go to beryllium, there are once again two shells. Then you will go to boron, there are once again two shells. Then you will move to carbon, there are once again two shells. And then nitrogen, then oxygen, then fluorine, all of them have only two shells in them. That means the number of shells indicates that the size should be same. But we observe that this size, atomic radius, it goes on decreasing. Atomic size goes on decreasing as we move from left to right in the periodic table. From S block elements to P block element. When you move from S block elements to P block elements along a particular period, you will find that the size of the atoms, that is the atomic radius, goes on decreasing. What is the cause? If they are having same number of shells indicates that the size must be same. But we observe size gets decreased. Why it decreases? Let's find the cause. In case of lithium, we know this lithium has atomic number of 3. That means there are 3 protons in case of lithium. Whereas beryllium has atomic number of 4. That means 4 protons. 3 protons means 3 positive charges on the nucleus. Whereas 4 protons means 4 positive charges on the nucleus. And the same way in boron, there are 5 protons. That means 5 positive charges. In case of carbon, this atomic number is 6, so 6 protons. That means when we move from left to right, number of protons goes on increasing, or you may say nuclear charge goes on increasing. Because we know that the charge on the nucleus carries positive charge on it. That positive charge on the nucleus is because of presence of protons in the nucleus. So this presence of protons is responsible for nuclear charge. So the charge will depend upon the number of protons. Greater the number of protons in the nucleus, greater will be the nuclear charge. So what is the role played by nuclear charge? We know that nucleus, it carries now positive charge on it. And the shells outside the nucleus, they contain electrons in it. These electrons are negatively charged. Their negatively electrons make these shells negatively charged. So what happens is, the proton present in the nucleus makes the nucleus positively charged, while the electrons present in the shells makes the shells negatively charged. And we all know that opposite charges attract each other. So what will happen? These 3 positive charges, 3 protons, will attract 2 shells towards it. 3 protons are attracting 2 shells in case of lithium. Whereas in case of this beryllium, there are 4 protons. That means 4 positive charges are attracting 2 shells. Because here once again, in case of beryllium, there are only 2 shells. And in case of boron, 5 protons, 5 positive charges are attracting 2 shells. In case of 6 protons, in case of carbon, 6 protons are attracting 2 shells. So now you can yourself imagine that what will happen when we move from left to right. Since the nuclear charge increases, intensity of nuclear charge increases, number of shells remains constant. So 6 protons will attract 2 shells more strongly than the 5 protons will do.
and these 5 protons will attract 2 shells more strongly than the 4 protons will do. And in the same way, 4 protons will attract these 2 shells more strongly than the 3 protons in the lithium. So what happens when the force of attraction increases on these shells will be attracted more towards the nucleus. So the shells and carbon are attracted more strongly than boron. That means carbon will be smaller in size than boron. Boron will be smaller in size than beryllium. Beryllium will be smaller in size than lithium. So it is a nuclear charge which is responsible for decrease in size from left to right along a period. Or when we move from S block elements to P block elements, along a particular period, the size goes on decreasing. It is because the number of shells remains constant, but the nuclear charge increases. This increase in nuclear charge leads to decrease in size. Now, one thing more. Let us come back to this group first. When we move from top to bottom, we observe number of shells goes on increasing. When number of shells gets increased, that means size gets increased. In case of potassium, you will now observe there are 4 shells. And presence of 4 shells makes this potassium larger in size than the sodium. As we have just now seen that on moving down the group, the size of the atoms goes on increasing because of increase in the number of shells. But at the same time, we observe that in case of lithium, there are 3 protons as you have seen because its atomic number is 3. Whereas in case of sodium, its atomic number is 11. In case of sodium, atomic number is 11. That means in lithium, 3 protons attract 2 shells, and in sodium, 11 protons attract 3 shells. And in case of potassium, 19 positive charges attract 4 shells. That means while coming down from top to bottom along a group, 2 things happen. One is number of shells goes on increasing, which leads an increase in the size of the atom, but at the same time nuclear charge also goes on increasing, and you have just now seen that increase in nuclear charge leads to decrease in size of the atom. So we observe here that 2 factors. One of the factors favors the increase in the size of the atom, and other factor favors decrease in the size of the atom. But we observe that while going from top to bottom along a group, the size of the atoms always goes on increasing. That means effect of addition of new shells is more prominent than the increase in the nuclear charge. So you might have understood what happens to atomic size along a period and along a group. In every group, whether it may be S block elements or it may be P block elements, you will observe that size of the atoms goes on always. It always goes on increasing because of the increase in the nuclear number of shells. Though nuclear charge also gets increased, but it doesn't have the equal effect as that of the addition of new shells. So the addition of new shells is more prominent than the nuclear charge. So this is one property, atomic radius or atomic size. After that, we have one more property, that is ionic radius. After atomic radius, we have ionic radius. Since we know that ions are formed from atoms, atoms get converted into ions either by loss of electron or by gain of electron. So what are ions? Actually, we have to study ionic radius. Ionic radius. First of all, let us see what is meant by an ion. Ion is a charged species, rather a charged atom. You can call it charged atom. Whether atom carries a positive charge on it or negative charge on it is called ion. So simply ions are of 2 types. One is cation, which is formed by loss of electron. Loss of electron, hence cation carries positive charge on it. Another ion is anion, and that anion is formed by gain of electrons, you know it, gain of electrons. And due to this gain of electron, this ion develops negative charge on it. So there are two types of ions, cations and anions. Cations carrying positive charge on them because of loss of electron, and anions carrying negative charge on them because of gain of electrons. So we have to see, since we are studying S and P block elements, you remember the outer sketch of this periodic table in this way. This is periodic table. These two groups are S block elements, and the groups on this side are P block elements. Generally, what we observe that S block elements generally they form positive ions. S block elements form cations. They form cations. That means they show tendency to lose electron. They have tendency to lose electrons. And as you know, the atoms which show tendency towards losing of electrons, such atoms are said to be electropositive in nature. Electropositive elements. So S block elements are electropositive elements. Because they lose the electrons and change into positive ions. We have to understand why these elements have tendency to lose the electron. They lose the electron simply by giving a small amount of energy. And that energy we know is called as ionization energy or ionization enthalpy. So why they have a tendency to lose the electron? Suppose if we will take the example of lithium atom. We know lithium has electronic configuration of helium and 2s1. He and 2s1. Or if you take the example of sodium, which is having atomic number of 11, its electronic configuration is neon and 3s1. And the same way potassium has argon and 4s1. That means if these elements will lose this electron, if lithium will lose one electron, it will now attain the electronic configuration similar to that of helium. And since we know that this helium is a noble gas, so by losing an electron, helium changes into a noble gas, into a stable electronic configuration. And the same way, what will happen to the sodium when it loses one electron? It will have electronic configuration similar to that of neon, and this electronic configuration makes sodium ion a stable atom. So these atoms, electropositive elements, or you may say group first element. Since group first elements, lithium, sodium, potassium, rubidium, cesium, and francium, these elements easily lose their electrons because after losing the electron, they attain stable electronic configuration. And same is the case with these elements: beryllium, magnesium, calcium, strontium, barium, radium. These elements have 2 electrons in their outermost shell, so they will lose 2 electrons and will attain the stable electronic configuration. So S block elements, why they lose the electrons and change into positive ions? The reason behind them is that after losing the electron, they attain stable electronic configuration. And in order to lose this electron, they need only a very small amount of energy, which we call ionization energy. So these elements of group first and second have low ionization energy, low ionization enthalpy, and because of this low ionization enthalpy, they get converted into cations. Now, let us come to anions. How anions are formed? Anions are formed by gain of electrons. gain of electrons. Here one is again the same reason. If we will take the example of halogens, there is fluorine, there is chlorine, then there is bromine. If you will find out their electronic configuration, fluorine has atomic number of 9. Its electronic configuration will be 1s2, 2s2, and 2p5. And if you will compare the electronic configuration of fluorine with neon, neon has an electronic configuration of 1s2, 2s2, and 2p6. This is the electronic configuration of neon. You will find here that this fluorine, it is one electron shorter. Its electronic configuration is just one electron shorter than that of neon. That means if we will provide one electron to fluorine atom, it will have an electronic configuration similar to that of neon. So for fluorine, it is easy to gain this electron to become stable. Otherwise, if it lose the electron, it will be more unstable. And if we wish that it should change into cation, then it has to lose 7 electrons. It is impossible for an atom to lose such a big number of electrons. So it is easier for fluorine to gain 1 electron and to attain nearest noble gas configuration of neon. And same is the case with chlorine. Chlorine has atomic number of 17, while as argon, the another noble gas, has atomic number of 18. That means this chlorine is one electron shorter than that of argon. If you will provide this one electron to this chlorine, it will get converted into a noble gas configuration. And same is the case with other atoms of the same group. So these p-block elementals, they prefer especially halogens, and then oxygen of the oxygen family, nitrogen of the nitrogen family. These elements prefer to gain electrons to achieve noble gas configuration, while as the other elements of these groups, they also attain noble gas configuration by either by gaining the electron and changing into anions, or sometimes they may form covalent compounds. So anions are formed by gain of electrons, and the cause of gain of electrons behind them is that whenever they gain the electron, they get stable noble gas configuration. So noble gas configuration is obtained either by loss of electron or by gain of electron. If an atom loses the electron, it changes into a cation, and if it gains the electron, it changes into an anion. Now we have to find what is meant by ionic radius. Now let's come to ionic radius. So what is ionic radius? It is its ionic size. It is similar to that of atomic size. Since atomic size is expressed in terms of atomic radius, and the same way we express ionic size in terms of ionic radius. And this ionic radius is the distance between the nucleus and the outermost shell of the ion, whether it may be cation or it may be anion. The distance between the nucleus and the outermost shell. ठीक है ना? तो आयनिक रेडियस की जहां तक बात है कि अब आयनिक रेडियस है कैसी, आयन की रेडियस जो होती है ये क्या है, आयनिक रेडियस का क्या होता है, व्हाट्स द ट्रेंड फॉलोड बाय द आयनिक रेडियस इन द पीरियोडिक टेबल. तो इस पे हम जरा सी बात कर लेंगे. आप ये पीरियोडिक टेबल में पहले पढ़ चुके हैं, बट स्टिल वी विल हैव अ लुक ऑन atomic radius and ionic radius of cations and anions here. It is very easy to understand. You have seen just now that lithium, sodium, potassium, they change. Lithium changes into lithium positive ion. Sodium changes into sodium positive ion. Potassium changes into potassium positive ion. This they do by losing an electron. You might have observed just now, lithium has electronic configuration of helium and 2s1, and sodium has electronic configuration of neon and 3s1, and potassium has electronic configuration of argon and 4s1. As I have just now told you that these atoms get converted into ions by losing the electron. So when lithium will lose the electron, it will change into lithium ion, and that lithium ion will have electronic configuration to that of lithium. This is lithium ion. That means lithium ion has got converted lithium atom has got converted into lithium ion by losing the electron. When electrons are lost, two things happen. One, that this shell in which there was electron, this electron has been lost. Now this shell has been lost. Shells are valuable, or shells are considered only when there are electrons in them. If there isn't any electron in the shell, then that shell is not considered to be the part of atom. So once lithium loses the electron, it loses the shell. Now you see, we have just now seen that in case of atomic radius, lithium has two shells in it. When this lithium changes, when this lithium changes into lithium ion, what will happen? It will have now only one shell, because the electron which was present in the outermost shell 2s1, that electron has been lost. So when electron has been lost, that means shell has been lost. Now you see, when there are two shells in the atom and there are only one shell in the ion, naturally the size of the atom, size of the ion will get decreased as compared to that of the atom. So one thing which you have noted here, that is size of the cation is smaller than the size of the anion. Number 1 point. Now, what is the reason behind it? One reason behind it is that generally the shell is removed from the atom while losing the electron. Or you may say that cation has lesser number of shells than that of the neutral atom. Number one. Then there is another reason behind it. You see, in case of lithium, there are 3 protons, and these 3 protons are attracting 2 shells, K shell and L shell. But when this lithium atom changes into lithium positive ion, what happens? 3 protons are there, but the number of shells is only 1. Now what happens? In case of neutral atom, 3 protons, 3 positive charges were attracting 2 shells. Now in the ion, 3 positive charges are attracting only 1 shell. That means this one shell will experience a strong pull towards inside because of larger number of nuclear charge, because of higher nuclear charge. So what happens? That this when an atom changes into an ion, effect of nuclear charge also increases. Effect of nuclear charge remains the same, but actually number of electrons goes on decreasing. In lithium atom, there are 3 electrons, while in case of lithium ion, there are only 2 electrons. Here 3 protons are attracting 3 electrons. Here 3 protons are attracting only 2 electrons. So 3 protons will attract strongly 2 electrons towards them. With the result, the shell will get attracted more towards the nucleus. It will come rather closer to the nucleus. When the shell comes closer to the nucleus, the size of the atom atom decreases. So the second reason behind the decrease in the size of the cation is increase in the nuclear charge. These are the main reasons behind the decrease in the size of the cation as compared to neutral atom. And one thing more which you shall note, that when we come down from top to bottom, the nuclear this ionic radius of the cation will go on increasing, because you will observe that in lithium there remains 1 shell, and sodium there will be 2 shells, and potassium there will be 3 shells. Sodium ion, I talk of ions. Lithium ion, there will be 1 shell, and sodium ion there will be 2 shells, and potassium ion there will be 3 shells. It is clear to you when you write down the electronic configuration, or when you will compare the ionic radius with the atomic radius just by taking the pictures of neutral atoms and ions into consideration. So down the group, this cationic size or ionic radius goes on increasing, but it is the ionic radius, it is the ionic radius of the cation. Now let's come to anions. Number 2. Anions. What happens to anions? Anionic radius. Let me first take the example of alkali metal. These are halogens: fluorine, chlorine, bromine, iodine, astatine. Fluorine, as you have seen, fluorine is having electronic configuration of 1s2, 2s2, 2p5. Then two shells are there. In case of fluorine, there are two shells. One is this K shell, another is L shell. Two shells are there in fluorine. And when this fluorine gains an electron, it changes into fluoride ion. And this fluoride ion has now electronic configuration of 1s2, 2s2, 2p6. That means here once again there are only two shells, K shell and L shell. That means when an atom gains the electron, number of shells remains constant. Number of shells remains. When number of shells remains constant, it indicates that the size should also remain constant. Size of the ion should not get converted, should not get changed. It should neither get increased nor it should get decreased. But one thing we observe, that in case of fluorine atom, neutral fluorine, there are 9 electrons, and at the same time there will be 9 protons. And these 9 protons will be present in the nucleus. That means 9 protons are attracting 9 electrons towards themselves. 9 protons are attracting 9 electrons towards themselves. But when this fluorine gets converted into fluoride ion, what happens? The number of protons remains the same, 9 protons in the nucleus. But 1 electron is added to the fluorine, and because of addition of that electron, now the number of electrons becomes 10. Now you can yourself guess what will happen. 9 protons attracting 9 electrons and 9 protons attracting 10 electrons. It simply indicates that these 9 electrons will be attracted strongly by the nucleus than the 10 electrons. That means 10 electrons are less strongly attracted by the nucleus. When electrons are less strongly attracted by the nucleus, what will happen? These electrons will go away from the nucleus. So when electron cloud goes away from the nucleus, that is, size of the ion will get increased. That means in fluorine, if this is nucleus, these are the two shells having 9 electrons in them. In case of fluoride ion, this is nucleus, there will be once again only 2 shells, but the electron cloud will get a little enlarged. Electron cloud will go a little away from the nucleus because the nucleus now doesn't attract the electrons so much strongly as it used to do in case of neutral atoms. So we conclude that anions are larger in size than neutral atoms. So this is opposite to that of cationic size than neutral atoms. Cations were smaller in size than the neutral atoms, whereas anions are larger in size than the neutral atoms. So if we will compare the size of cation with that of anion, so anion will be always larger in size than the cation. So when we talk of ionic radius, since we have two types of radius, cationic and anionic radius, cations and anions are there, we observe now that anions are always larger in size than the cations. This point should be noted. And when we compare the anion with that of neutral atom, anion is larger in size. And when you will go down the group naturally, the number of shells goes on increasing, so the anionic radius will also go on increasing. So one thing which you should keep in mind, that ionic radius goes on increasing down the group both in case of cations as well as in case of anions. Number one. Number two, which you should keep in mind, that cations are always smaller in size than the neutral atoms, while as anions are always larger in size than the neutral atoms. And number three, cations are smaller in size than the anions. And one thing more, which is very important, that is when you will compare different ions. For example, if you take the example of lithium ion and beryllium ion, or sodium ion and magnesium ion. Sodium ion generally carries +1 charge, whereas magnesium ion carries +2 charge. It is because this magnesium attains noble gas configuration by losing 2 electrons. So in case of magnesium nuclear charge is stronger than the sodium positive ion. Or simply, here are two positive charges, here is one. The increase in the positive charge will lead to the decrease in the size of the cation. So the cations which are having more charge on them are smaller in size than the cations which are having less charge on them. This thing you should keep in mind because it is very important. In the same way, in case of anions, there are anions carrying different charges. Fluoride ion has -1 charge on it. And while as there is oxygen, sulfur, selenium, oxygen carries -2 charge on them. And if you will come to nitrogen family, nitrogen will have -3 charge on them. So we have seen that when electrons are added, in case of fluorine, 1 electron is added. And because of addition of that 1 electron, the electron cloud increases in size and goes a little away from the nucleus. And when there are two electrons added, that means when there is -2 charge on the atom, it means this atom has gained 2 electrons. So when 2 electrons are added to an atom, naturally their electron cloud will go much farther from the nucleus. And same will happen to nitride ion, where the electron cloud will go much larger, still much larger away from the nucleus. So in case of anions, if the charge, negative charge gets increased, size gets increased. In case of cations, if the charge gets increased, size gets decreased. Suppose here is one more ion, Al+3. Sodium ion is larger in size than magnesium ion. Magnesium ion is larger in size than aluminum ion. That means as soon as you observe that the charge is increasing, positive charge is increasing, size is decreasing. While as in case of negative ions, an ion having greater charge is larger in size than the ion having less charge. So effect is somewhat reverse in case of cations and in case of anions. So this is about atomic ionic radius. So two properties we discussed today. One is atomic radius or atomic size, and another property is ionic radius or ionic size. Inshallah, tomorrow we will discuss a few more properties. For till then, thank you very much. Inshallah, I will give you some assignment tomorrow, and whatever we have studied so far, let you go through it more keenly so that you can attempt your assignment much perfectly. So I hope that you have understood these two topics which you have already discussed in case of periodic table. But here, since we are studying the periodic table in detail, S block and P block, as I have told you in the beginning, that then we will study D block, then F block in case of in 12th class. So S and P, S block and some P block elements we are discussing in 11th, and other P block elements in 12th class. This is why we are carrying a joint class for these lessons. As soon as we will complete these individual properties, then we will go for individual classes. तो आज के लिए इतना ही. Hope you might have understood it fully. Thank you very much.